Hello, welcome to part 4 session of 8085 programming model. This session highlights about representing the programming model in the application through programs. If we have an overlook or what we are going to see in this session, we will see how an instruction is shown in timing flow, how an instruction can be written in various formats in assembly pattern as well as in hex code pattern. If we go with a very simple program, select two registers and perform the addition on these register operations. A simple question is raised saying like loading of one of the register accumulator through immediate addressing mode, selecting another register B and loading it with immediate operation and performing the addition. A simple program is formatted like this. So how many ways can we show the instruction? When we have to program these instructions, when we have to program these registers into instructions, we write them in mnemonics format. So what we represent here is a mnemonic arrangement. Apart from addition, MVI, MOV, we have many popular instructions like LDA, load accumulator, STA, store accumulator, compare instructions, load pair immediate values, load address immediate values. So load and store instructions play a very prominent role in 8085 design. If we use this simple program to understand, MVI stands for move immediate data 5 into accumulator, move immediate data 4 into B register. How the system understands these representations whenever we perform these add operations? How many locations does this instruction occupy? All these things can be analyzed through memory occupancy and its representation in hex format. If we first go, what is the constitution of instruction? Any instruction will be classified into size of its instruction arrangement. So if I say, if we look over any instruction, we could answer few questions like, what is the type of addressing mode in that instruction, what type of operation or instruction set is utilized in that instruction, then what is the size of the instruction. So three questions could be raised with respect to any one of the given mnemonic. So if we see any instruction is a 1 byte instruction, if it has only occupancy of 1 memory byte, so nothing but 8 bits. If the instruction is occupying only 8 bits, then it is treated as 1 byte instruction. One of the example is, this is an implied addressing mode instruction, HLT, short form of halt. It requires only one hexacode format called 3A, and 3A occupies only 1 byte of memory area. So it will be titled under 1 byte instruction. So if we represent the same in 2 byte and 3 byte format, so 3 byte instructions come under with larger occupancy of 3 locations. 2 byte instructions come under the occupancy of 2 locations. If we select the same instruction we had shown in the program is very simple. 5 is loaded in accumulator, 4 is loaded in B register, both are added. How simple the representation is. Analysis here is how they are being stored inside the memory, how much locations or how is the representation of these instruction inside the processing device. So processor doesn't understand the English, it will show some hexacode representations. All the opcodes will be having 8-bit hexacode representation. So definitely in any instruction, at a minimum, any instruction will be of 1 byte size. So definitely we will have an opcode. Though we might have one operand, 2 operand, or multiple operands, or no operands in the instructions, definitely opcode should be there. So basically any instruction will be at a minimum of 1 byte. 2 byte instructions are those which occupy 2 locations, nothing but 16 bits location inside the memory. Similarly, 3 byte instructions occupy 3 locations inside the memory, and their size will be represented as 3 byte location. So suppose if I store an instruction at some X location, the next available location will be X, X plus 1, X plus 2 occupied. I am going to get the next empty location as X plus 3. So 3 byte instruction is something represented in an example here. opcode, then operand which is of already 16-bit size, and opcode. Together they will occupy 24 bits or 3 bytes. So if we plan the same thing with our earlier question, how it will be represented, that will be a part of interesting observation. So the same program written, then how it is occupied. System understands it with respect to hex codes or binary codes, and if we are storing, for example, the first instruction at an location called 2000, what will be the next available location is, it is a 2-byte instruction, so 2000 and next continuous value, consecutive value 2001 will be occupied, and the next available location will be 2002. Similarly, this instruction is also 2-byte size. So as looking to an instruction, we can answer some questions saying like, what is the addressing mode of this instruction? It is, what type of addressing mode it is? It is immediate addressing mode. Then it is a data transfer instruction. Then what is the size of this? 2 bytes. So what will be the next available address for us is 2004. What about this? This is also a 2-byte instruction. So next available address for us is 2006. This is the way how the system sees internally. This is user area, how the user views the program, and these are some internal calculations, how much memory this program has occupied. Is it suitable to fit in 64 KB of memory? Very simple, it has occupied only 7 bytes of program. So out of 64 KB, 7-byte program is quite simple. Similarly, all such other application programs will be fed inside the memory in this pattern. Now if we see how the system operates is, at what time move will occur, at what time add will occur, at what time 5 will go and sit in A, we can see this using some timing diagram representations. For example, look at this instruction as MVI A, 5, how this operation is carried out. So the general thing that will be continuously going inside the system is clock. It's a continuous heartbeat to the processor going on. For instance, at a address value called 2000, we have written this instruction and the instruction has been generated. What will the instruction decoder do here? So what is this procedure called is generating of address and obtaining the instruction to decide what to do. We consider it as fetch operation. What we have done is somewhere in 2000 location an instruction is stored. How is this instruction stored? Inside the memory is in format of binary code. What is the first binary code obtained? Obtained, we are using the word obtained, so we are considering it as the read operation. So after this, analysis will happen in the decode section. What will be the decode section doing? What to do with this? It is saying MVI, go and get a value called 5. And how to obtain 5? By going to the next address of 2000, saying like generate a continuous clock cycle. At the next instant, we need to transfer this 5 into A. This is execute operation. How this execution happens? When we go to 2000, we will find 5 there. And that 5 is obtained and it is been stored into accumulator. Is it read operation or write operation? Again, we brought it from memory and stored internally. It is a read operation. Every time we can make a beautiful observation here is ALE. At the very first instant, a strobe signal is generated to say we are generating some valid address. Similarly, some validity strobe signals will also be there for data. This is what we are performing. Memory or IO operation, we are reading here. We might be working on IO, we might be working on memory. All those indications can be shown in form of signals. So to learn about any microprocessor or microcontroller, we can learn it through architecture details, block diagram, or through its programming model, or through its timing representation. So these are all some discussions carried out with respect to 8085. If we have a simple conclusion on what all been discussed with respect to 8085 microprocessor is, the prominent company Intel has been the leader of developing this microprocessor. then its internal basic features are as listed. If we want to know about any processor, basic details should be definitely known to us. And 8-bit microprocessor 8085, it has 16 address lines through which memory accessibility up to this, and some programming features. So these are some of the basic overview we could provide over 8085 microprocessor. So here we end up the discussion on 8085, and thank you for joining the session. Thank you very much.